Okay, welcome back, guys. We're going to go through a couple more Dijkstra's algorithm examples that are a bit more complicated. I don't just want you to watch these videos, I want to work along as we go, so you'll pause the video and we'll do it a row at a time. So don't just watch it, be an active participant and have a go. So we've got two here, we've got one on the first page and one on the second page. We'll start with the second one first because it's a bit easier. So we want to go from A to H in the shortest distance, and we want to use Dijkstra's algorithm. Now I've already gone ahead and done it via inspection and just done by trial and error. I've gone A to B to D is 15, and then another 10, and I think it's 25. Dijkstra's should confirm it. It'll also be A, C, E, G, H. That'll also be 25. So it'll be interesting to see what it comes out with. Let's have a go. Now, we start off with A, and then we'll put all the other ones, A, B, C, D, E, F, G, and then H. And then we'll have a go. Maybe I was wrong with my inspection. Dijkstra's will confirm or deny it. So I'll zoom out a bit. Okay, as I said, we're going to do it by row, so hopefully you've drawn this out in your book. Let's have a go. I want you to do the first row. Okay, so pause the video and do the first row, and then we'll check it together. Okay, we should be back now. We'll have a look. A to B is 7, A to C is 5, A to D doesn't go, A to E, F, A to G, and A to H. So we should have boxed C, and that's the one we're going to do next, and we're going to add 5. C to B is 3, 3 plus 5 is 8, but our numbers only stay the same or get smaller. So even though it should be 8, this 7 takes precedence. Our box number comes down. C to D is 11, so we've got 16. C to E is 5, 5 plus 5 is 10. C to F doesn't go. C to G doesn't go, and C to H doesn't go. So we're going to look at B next and add 7. So guys, have a go at that row B and then come back to me. B to D is 8. 8 plus 7 is 15. That's good, it's getting smaller. B to E doesn't go, but we've got a 10 here, that comes down. B to F doesn't go, B to G doesn't go, and B to H doesn't go. So we're actually going to look at E next. We're going to add 10. So we've got 7, 5. Okay, E to D. Whoops. So go ahead and try row E, guys. E to D is 4, so that's what we want. We get smaller to 14. E to F doesn't go. E to G is 10 plus 10 is 20. E to H doesn't go yet. So we're going to do D next, and we're going to add 14. Gets quicker as you go. Just try and box your numbers and keep it nice and neat. D to F is 6. 6 plus 14, we've got 20. D to G is 5, and we're going to 19. That's good, it gets smaller. And D to H doesn't go. So we're going to box the G, and we're going to add 19 each time. And we're going to bring down our box numbers. Sorry, it's a bit messy, guys. Okay, and then we wanted to say G to F is 4. 4 plus 19. No, it's not going to go. It's still going to stick as 20. And then G to H. G to H is 5. So we're actually at 24. Okay, we're going to box F. So I might have been wrong with my initial inspection. That's the beauty of Dijkstra's. F and plus 20. 7, 5, 14, 10, 20, 19. And we go F to H. F to H is 6, so we get 26, but 24 stays. Okay, let's have a look with our backtracking. So I go up, I follow the 24s for as long as I can. Okay, I'm in G, so I go across to G and I follow those 19s up. Okay, I'm in D, so I go across to D. I'm in 14, and then I go back to E. So this is the one where I'm going the wrong way because I stop here, my 14's run out, and I'm in row E, but row E is actually, or column E is back. I follow my 10s up. 10, I'm in C, and I'm out. So let's just go for a different colour then, and let's just see if this is true. So this is telling me to go to A to C, then to E, then going up to D, and I'll save 1 that way. So guys, I did not do that on purpose. This is a legitimate mistake. This just shows how good Dijkstra's algorithm is. Okay, initial inspection was false, I was wrong, and this Dijkstra's algorithm has confirmed the shortest distance is actually 24, and it's A, C, E, D, G, and H. A, C, E, D, G, and H. A, C, D, D. Yep. So that's the beauty of Dijkstra's algorithm. Okay, shortest path problems, it'll do it. If you do it correctly, it'll always get it. Okay, let's have a look at this one. Now this one's got a funny backtracking as well, I think, from memory. So let's have a look. We'll go A, then we'll go B, C, D. I'll skip E, I'll finish with E because that's where I'm going to. B, C, D, F, G, and then we'll have E to finish up with. So we'll go ahead and do it again row by row. So go ahead and try row A. Pause your video and then come back. Okay, we're back. A to B is 20. A to C is 8. A to D doesn't go, doesn't go, doesn't go, doesn't go. So we're going to do C. And we're going to add 8 each time. So we bring that down. Let's have a look. C to B is 10. 10 plus 8. It gets smaller. That's what we want. C. Whoops, I've done this wrong, guys. Whoops, 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 whoops. Start again. Went too quick. A to B is 20. A to C doesn't go. It's A to G, which is 8. So that's what happens when you rush, guys. So I'm actually going to do G first and add 8. So G to B is 10. So that becomes 18. G to C is 4. That becomes 12. G to D doesn't go. G to F does. It's 40. 40 plus 8 is 48. G to E doesn't go. So I'm going to do C now. And I'm going to add 12. C to B doesn't go. So we're going to box that. C to B does actually. C to B does, it's 5. 5 plus 12 is 17. That gets smaller, that's good. C to D does. It's going to be 42 because 30 plus 12. C to F does. Okay, 35 plus 12 is 47. That's okay, it wants to get smaller. C to E doesn't go. So I'm going to do B next. I'm going to add 17. So hopefully guys you're doing this row by row. B to D is 20. Okay, and we get to 37. That's okay, it wants to get smaller. B to F. B to F doesn't go, so we're going to go 47. B to E doesn't go. So we're going to do this one, this 37 one, and we'll do D, and we're going to add 37. 17, 12, 37, 8, they all get boxed up. And hopefully we need these numbers to get smaller. Okay, D to F is 8. 8 plus 37 is 45. That's okay, it gets smaller. D to E is 57. 20 plus 37, and we're going to box F. We're going to add 45 to it. F to E is 11. 11 plus 45 is 56, and it gets boxed up, which is what we want. Okay, apologies for that slight little step up at the start where I did C instead of G, but it happens. Okay, this backtracking is a little bit weird because we don't have any 56s above it. Okay, so we've only got 56 here, but we look across and we go, okay, I'm in F, so I go across to F. I follow the 45s up, and then I go, I'm in D. I follow the 37s up, and I'm in B. I follow the 17s, and you might think you're done, but we're not. Okay, we want to be up to here, so we go, okay, I'm actually in C, so I go across to C. I follow the 12s up, and I go, okay, then I go across to G, and I'm out. So this backtracking is weird. You always follow the numbers up, and then you stop when the numbers run out, and you go across to the column where you're finishing up. So what did I do then? Every time I pivoted, I went from G, and then I went across to C, then I went to B, then I went to D, then I went to F, and then I went to E. And I forgot about A. Okay, so I went A, G, C, B, D, F, E. Okay, that's my shortest path. Okay, guys, that's about as hard as they're going to get. But with this systematic approach, you can't, if you do it correctly, you're finding out the shortest path.